All right. The next section deals with carboxylic acids. This is a really big part. This is almost as big as alcohols. There's a lot of uses for this. First of all, let's define what a carboxylic acid is. Remember, this is going to involve an alkyl group. I'm sorry, I'm saying alkyl. It's a carbonyl group. The two attachments here. One on the left is the alkyl group attached to this. And then this right here is going to form an OH. And this is a big thing right here. We'll get into that in just a little bit. These are incredibly stable compounds, particularly when they lose their hydrogens, because they are acids. Now we can write this as RCOOH. R2. I guess I have liquid. So the naming systems get really goofy here. The thing is, a lot of these compounds were known in days of Rome and Greece, and back in the pre-Christ era. Of course, they didn't name them the way the IUPs named them. They were named based upon where they found them. So we're going to look at both aspects of this. So that's the direction we're going to be going with that. But before we get into that, let's get into physical properties, which are going to be pretty obvious. Because of both of these oxygens right here, this is going to be incredibly polar. So this is a polar molecule, and the meaning of that, of course, is that it's going to be soluble in water. Up to around 6 carbons. The fact that you have an H here on the O is going to make this intermolecular bond thing a hydrogen bond. Which of course means it's going to be strong bond, so it's going to be difficult to pull it apart. So that's going to give it a high boiling point and melting or freezing point, depending on how you look at it, and low vapor pressure. So in fact, this is going to be held together very tightly. Not very much is going to come off in the dissolving of this. In the ability to release molecules from the bonds. So this is going to be low vapor pressure. Not very much pressure is going to be coming off of this stuff. Very little vapor. Although when you dissolve it in water, for reasons we'll get into, you'll actually smell it better then than if it was in pure form. And that's a really interesting aspect of this. So those are your physical properties. And then uses for this. The human body uses this to make fatty acids. You get into biochemistry, you find out what fatty acids are all about and their usefulness. We also use them to make soft drinks and food. Okay. We also use this making synthetics. Rubber. We make rubber with this. Textiles. Pharmaceuticals. Like I said, this is an extremely important part of oxyorganic compound. And rather recently, this is a fascinating one. You want to get a chance to read something about low-level chemistry in the form of the size of the molecule. This is it's used to make metallic nanoparticles. When they say nanoparticles, they're talking about particles the size of a molecule and attached to a metal. And it has various uses. It's incredible stuff. All right, so